So here's section 2.5, ordering integers using number lines. Okay, so number lines compared to the chip model, which I know we haven't seen yet, but you'll see in a minute. Uh, it's really, I think, a better way of helping students to see the ordering of integers. So up until now, theoretically, in this course, we've only shown them whole numbers. And they have an excellent sense of magnitude that 50 is greater than 40, and the fact that when we deal with negative numbers, that's reverse can be confusing. So they'll think negative 50 is greater than negative 40 because they're thinking of magnitude rather than relative location. And when we look at the chip model, the chips have different colors, but the chips are really representing magnitude as opposed to position on the number line. So something that shouldn't be shocking to them, but you might want to bring up, two numbers are equal or one is less than the other. Okay, so this is the first place we actually don't use inequality notation in Unit 1. We just use the words is less than or greater than to have them compare. But we start to introduce these inequality symbols. Okay, you'll notice in the homework we have them answer 3 questions. So we'd have them say 2 is to the left of 5 on the number line, therefore 2 is less than 5. And then we also have them use this symbol. We also have them do this in 2 ways, so they need to understand. Let me write this over here. Okay, so this is 2 is less than 5. And equivalently, we can think of this as 5 is greater than 2. Okay, so typically when we read this from left to right. 2 is, this is the less than symbol, this is 5. But we want them to know that this is equivalent to 5 is greater than 2. Okay, so being able to see this as this open side of the inequality sign pointing towards 5, okay, means that 5 is the bigger number. So we want them to kind of begin to adjust to see those two simultaneously. We have them write them both out, okay, but we want them to connect those ideas. Okay, so here, this is a general idea. You have them plot them. They're great at plotting them. One thing to make sure, for some reason, and I have no idea why, if you know why, please tell me, they like to plot numbers above the number line instead of directly on the number line. You can imagine that'll be especially problematic when we're working in 2 dimensions and they start dealing with graphs. So I make sure they plot directly on the number line. Okay, we say things like write the number which is further to the right. That means that the number further to the right is larger, or actually we want to use the word greater, so I'm glad I said that by accident. Smaller versus larger. These terms really seem to connect to the idea again of magnitude. Okay, so we like to use the words less than or greater than when we're talking about negative numbers, because that doesn't seem to refer to magnitude, or at least we want them to get to associate less than greater than with relative position on the number line. Okay, here are those chips I've been talking about. Okay, so you'll see the chips that you have in your classroom. They're 2-sided. They are yellow and red, and yellow is going to represent positive chips and red represents negative chips. Okay, so here, excuse me, here, since the book isn't printed in color, I use these chips that have the plus and the negative signs, and that kind of reinforces it as well, what the signs mean. So you probably aren't shocked. To represent positive 5, we'd have 5 positive chips, negative 5, we'd have 5 negative chips. Okay, so here again, they're going to start to visualize. Notice the magnitude of these numbers, meaning the number of chips is the same, but this is representing a different value based on the fact that they're negative chips. In this problem, something you really want them to see is, notice we say, hey, what's this? 3. What's this? -4. And here they start to think, what on earth is this? So we basically want them to begin to realize that something, a representation like this, when we have chips of different signs, so we're not even going to think of this as addition or combining, although that's going to come into play later. But we want them to see that a positive and a negative cancel each other out. So plus $1 minus $1 cancels each other out. So after the red and black pairs cancel each other out, what is the simplest form of this number? So we can think of this as +5 combined with -3. How could we write that most simply? Okay, so 3 of the negatives would cancel, and this is the number 2. Here, one pair would cancel. Okay, so simplifying or writing it as a number involves canceling until you have chips of one color. Okay, and for this, I would give them some chips and ask them to represent them in multiple ways. Okay. Language and notation of integers. Okay, so you want to bring up that we use the positive symbol and the negative symbol in multiple ways. Before, we only use this as addition. Now we can also use this to read +4. So we want, and it's hard for us to use this language as well because we have a simultaneous understanding of what we mean in context, but we want to use the word plus when we mean addition and positive when we refer to a number sign. So, of course, addition and positive numbers are connected when we start working with adding and subtracting, but we want them to see the difference between the operation and the sign of a number. And then to make it worse, of course, half the time when we want a positive number, we don't write the positive sign. So when we have a negative number, we absolutely write the negative sign. But originally, this symbol always meant subtraction. Now it can mean subtraction or a negative number. And remember, we also use this or can use this as the opposite of 4. Okay, so really try to get them to say the word minus solely for the operation of subtraction, and if they're talking about the sign of a number, a negative, and they can also use the idea of opposites. Okay, so here, even though we haven't gotten to operations yet, so they'd write this as -6, they could write this as the opposite of -6 or -6. That one doesn't seem to make as much sense. It's not traumatic to say -6, but we like the opposite of -6 here just so they can think of it as taking the opposite of this to get a positive value. Okay, and then here again, we haven't done operations yet, but we want them to start to see that this is not -3 plus 2, it's -3 plus 2, or it's not -3 positive 2. Okay, so you can see with that language, what would -3 positive 2 mean? Is that subtraction? In addition, this is also a positive 2, but we don't say that. Okay, so hopefully you're starting to see how this language is really something that's important for their understanding. If you're using these words, that will help and they'll start to get that language acquisition. But if they don't understand or if they start to say these symbols differently, and then they'll start to build a different understanding based on their meaning of them. So we really want them to use the correct language. Okay, and let's stop this video and we'll do adding